Good morning, everyone. Mechanics of Materials, Chapter 9, Stress Transformation. More circle in stresses. Christian Otto Mohr was a brilliant German engineer born in 8th of October 1835 in 19th century. He developed a circle which made this stress calculation far simpler than the formula. Mohr studied engineering at the Polytechnic Institute of Hanover. Nowadays, it's known as Leibniz University in Hanover. He just gave us an approach if we have an element and we want to calculate the sigma and uh, tau at any arbitrary angle. So if we rotate our sample with any arbitrary angle of theta, then we want to calculate the new sigma prime and tau maximum, how we can approach that problem. So let's just assume this is our original uh, origins like x and y, and we want to move to a brand new house by angle of theta like x prime of y prime. We do know our stresses in uh, x and y direction, and we want to calculate them in their brand new house of x prime, y prime. So definitely sigma x moves to sigma x prime, sigma y moves to sigma y prime, and if you do the formula, sigma x prime can be calculated from this formula, and sigma y prime similarly can come from this formula. If you want to know how we can calculate them based off a formula, that's a simple calculation in a summation of forces in x and y direction goes zero and gives you this formula. And if you want, I will provide you with the link of the video related to how to get this formula from the exercises from the formula. But for now, we are focusing on how we can get them from the Mohr circle, which is far simpler. So sigma x prime, sigma y prime, and definitely tau xy moves to tau x prime y prime as well. And they are from formula. And if you want to get them from the Mohr circle, sigma maximum is sigma average plus a radius, sigma minimum is sigma average minus a radius, and you just need to calculate the radius based off the shape which is from this formula. You can see how it's made it far simpler than the formula itself. And when you see it graphically, let's verify how we can get these things on the circle. If you draw the Mohr circle, the y-axis is shear stress, which is tau, and x-axis is sigma normal or normal stress, which is sigma. And if you have 2 points like x and y, it translates to x and y, sigma x and tau xy, and the other point sigma xy minus tau xy, because this is below the y-axis. And definitely you can see the center point, this is origin, and sigma average is center point. If you add the radius to the center one, this is a radius, you can reach to sigma maximum. And if you subtract a radius from the average, you will get to sigma minimum over here. We'll review that as well. And tau maximum, you can either travel far down here or up here, which exactly the radius of our circle. Tau maximum is equal to capital R. Definitely sigma center line. If you have 2 points like sigma y and sigma x, you want to see the center line. This is sigma y from the origin. This is sigma x from the origin. Center of them definitely is average of them. That's the center of our circle, Mohr circle as well. And if that's the case, if you want to calculate the radius, this is hypotenuse of our triangle. So this distance, as you can easily see, this is sigma x minus sigma y over 2. Because if you have it like over here, this is sigma x, up to here is sigma y. And if you want to have this distance, that's sigma x minus sigma y. And if you divide it by 2, it just gives you this part. And this is tau xy, because This is x and y. Our y is nothing but tau xy, which is provided here. So our hypotenuse is a square root of sigma x minus sigma y over 2 squared plus tau xy squared, which you can easily get the radius. Then you can easily calculate sigma maximum or sigma minimum. And likewise, one can say, if I want to calculate tangent of 2 theta p, 2 theta p is the angle which rotates us from the original place to the maximum plane of stress. You can easily see this is that one. And that's definitely tangent is rise over run. This is our rise tau xy over sigma x minus sigma y over 2. That 2 jumps to the numerator and it just gives us tangent of 2 theta p is 2 tau xy over sigma x minus sigma y. And that's how simple you can calculate your stress with Mohr circle. Thank you. We'll solve some sample problem.